Okay, let's begin. We are up to 9D, confidence intervals for means. Now this is divided into three parts, 9D.1, 9D.2, 9D.3. We'll begin with just 9D.1, but my suspicion is we'll fly through it and we'll be able to get a start on 9D.2. Now, what we're doing is we're talking about a confidence interval. So this should be pretty new for all of us, something we haven't really heard of before. And it's a pretty important technique when it comes to statistics. So we're going to be doing it for means, and then later, when we get to 9F, we'll be doing it for proportions. So just to revise for you, we have a distinction between a population and a sample, right? Okay, so the population refers to the whole group. There's the population of year 12s at Tennyson Woods College, and you guys are a subset of that. You guys are a sample. We would assume that the statistics about you represent or indicate the statistics about the population, okay? So if we were to survey every year 12, and the example I've got here is about height, and find the average height, that would be the mean of the population, okay? And similarly, the standard deviation of the population. For a sample, the notation we use is lowercase x with a bar on top. That is the mean, and we use lowercase s for the standard deviation. Now, for a confidence interval, this is the formula that we're going to follow. We can use S and sigma if we don't have sigma, okay? So we can use S as a substitute for sigma, but we'll always be using X bar. Now what a confidence interval is it's a statement about the window within which the mean lies. So we'll get straight into our example here, and I'll show you what it means. So we have the height of 40 year 12 students was measured, and the observed mean was 178 centimetres with a standard deviation of 8 centimetres. Find the 95% confidence interval and interpret. So this is the formula for the 95% confidence interval. There are other levels of confidence that we will investigate in a moment, although 95 is the most common. So all we're doing is going to sub in the information we're given. We've got X bar is 178, that's the observed mean. We've got the standard deviation is 8. And we're just putting it into the formula. So we're going to have 178, take 1.96, multiplied by 8 on top of the square root of n. Now the sample size was 40. And so what you can, I won't put that out just yet. Let's write it up. Okay, so we're just going to evaluate the left-hand side and the right-hand side, and so we have that to 3 significant figures. Now, Crunchy, I've got a book for you. The pass. Okay. So I've got 175.5. And we've got 180.47. 180.4. Okay, so then when we round these, we've got 176 and 180. Okay, so here comes the interpretation. This is a confidence interval. We've performed a sample of 40 people, 40 year 12 students, and based on the confidence interval, we're saying the true mean lies between 176 centimetres and 180 centimetres. We don't know what it is, but we're 95% confident that it's in that window. Okay? So let's make that statement. We are 95% confident. The true mean of the population. Okay, very good. So it makes a bit of sense. All right. So we're using a sample to make a statement about, well, where does the true mean, the mean of the population, lie? Because the mean of the sample is not necessarily the mean of the population. Okay, rather we're just using it to tell us properties about it. Now, a couple of things to point out. If we have a look at this formula here, okay, we have divided by the square root of n. All right, we're dividing the standard deviation by the square root of n. Now that means the larger n gets, the larger our sample gets, the smaller this number here is going to be, which means we're subtracting less off the observed mean, which means our observed mean is getting closer and closer and closer to the population. That's what you expect, right? The larger the sample, the more accurate your observed values are. Okay, that's the first thing. The second thing to point out is this 1.96. Where does that come from? Because I said we can have other levels of confidence. And in fact, this number here dictates how confident we are going to be. So flick over the page. And I've got a table here exploring different levels of confidence. And it's important for you that you know how to calculate those values. Those values of what we call Z alpha on 2. All right? What they are is a Z-score under the Z distribution, such that the area is 95%. Okay, so we know from our Z distribution has a standard a mean of 0, standard deviation of 1. Now, we saw for a 95% confidence interval, the values are 1.96. So what that means is this area is 95%. All right, 0.95. If we want a confidence interval of 80%, we're going, what are these Z-scores such that this area is 0.8? So that's how we can calculate other values of Z-score. So let's do it. Let's do it for the 97% confidence interval. Let's say we want to know the area is 0.97. Let's determine these values of Z alpha on 2. So what we do, I've listed the calculator instructions there. We're going into inverse normal. All right, it's an inverse normal calculation. So menu, statistics, distribution, normal, inverse normal. The tail is central because we have a centralized area below and above the mean. Area is 0.97. We want the 97% confidence interval. Okay? The standard deviation for a Z distribution is 1 and the mean is 0. So we're putting that information in and we'll process that. Central 0.9710. We've got minus 2.17 and 2.17. All right, so that's how we can calculate other levels of confidence. And I've got a table there, and they tend to use 95's the most common, they use 98 and they use 99, and occasionally others will pop up as well, but they're sort of the main ones. And so all we would do if we want to calculate the 97% confidence interval is we'd be changing that number from 1.96 to the 2.17. Okay? Now it says below, find the 90 and 90% confidence interval for the year 12s. How does it compare? So what I'm going to do, let's do the 99 manually. All right. So I'll just clear a bit of room off here. I'm going to leave this up because this is our 95% confidence interval. And let's put our 90 here and we'll put our 99 here so that we can compare them. Okay? We can compare the confidence intervals. So I said we'll do our 99 using the manual technique, and then I'll show you how we can use our calculator. So for the 99% confidence interval, we're following this formula, except we're changing this number to, now from our table of values, so we don't have to calculate this one, it's in our table of values, 2.58. All right, so everyone see that in their table of values, 99% confidence interval corresponds with 2.58. And so then the formula is going to be 178 take 2.58 times 8 on the square root of 40, less than the mean, less than 178 plus 58 times 8 on the square root of 40. All right, so put that in. So my number now 2.58. So I've got 174.7, which is 175. Okay, so now for the 90% confidence interval, I've shown you how we can calculate them manually using this formula, but there is a calculator technique as well. And so I've listed the instructions there. It says we can also use technology to perform these calculations for us. So we go into statistics, we press interval, which is F4, Z, and 1 sample, okay? We need to have our data as variable, our confidence level, you can see our standard deviation, our observed mean, and the number of samples. So let's bring up that criteria for us. Our confidence level this time is going to be 0.9. We want 90% confidence. Standard deviation is 8. Our observed mean is 178, and our number of samples is 40. Now, I might just put more detail on the 95 just to make one point here. Okay, so what I want us to observe here is that as we increase the level of confidence, the window gets wider and wider. All right, and that's going to be true because as we increase the level of confidence, this number gets bigger, which means it has more weight on the subtraction from the observed mean. Okay. And of course that's going to be true as well. If you want to make a statement that you're 99% confident about being true, well, you need to include more possibilities than if you're just making it's 90%. Because there you've got 10% error. Here you've only got 1% error. And so we need to have a bigger margin of possible error. All right. So that's confidence intervals. So we've introduced you there to how we're going to calculate them. You can just go straight to your calculator. You very rarely need to calculate them manually. The only circumstance I've seen them pop up manually in the exam in the past is they'll have something like, they'll have boxes here for you to fill in. So they'll have something like this, let's take, and then they'll have a number here, and then they'll have 2 boxes here, and they want you to fill it in, okay? So that's the only time I've ever seen it pop up manually. Otherwise, you're just allowed to straight away use your calculator. You don't get marks for writing the formula out or anything like that. Okay, so any questions about 9D.1 there? All right, let's get started on that, see how we go. Rip in, enjoy it, it's good fun exercise.